Ladies and gentlemen, I present to you Jack Marsh's equation. There you go. You can see it there. That is the equation. X cubed minus 27x squared plus 242x minus 100 and... That's not right. Sorry. That should be 720x. No, sorry. 720 is equivalent to 0. So you can see that there. Yes. That is Jack Marsh's equation. It's a cubic equation. As you can see, it has the highest power of x is 3, and I'm going to show you how we get this equation. Now, obviously, you can use your online cubic graphs solvers to solve this. We'll use it later. I'm also going to just go over what Jack Marsh wants. So, Jack Marsh came up to me with a challenge, and this challenge was to create a shape, create these numbers out of 3 shapes. He wanted I think it was a hexadecagon. Yeah, hexadecagon, a square, and I think it was a hexagon. So I'm pretty sure it wasn't, but we'll do it to these anyway. So I didn't want to do a regular one. I did an irregular shape, sort of, somewhat. So you can do it by doing a line at about a 45-degree angle. That way, you go back down to try to get about the same distance around. You go up again. Trying to get these equivalent lengths sides, like that. This is going to be one of Jack Marsh's 3 shapes. It's going to be somewhat square-like. Then you go like this, I believe. That. There and about there. Now let's just tidy this up because it's a bit not quite accurate. Let's drag that along there. Center it a bit more. Get rid of that. Redo that bit. Should go about there. So you guys kind of get the point of what this shape is like to a certain extent. Let's delete that. I'm just going to tidy this shape up a bit. Just going to try and get these at right angles if we can. If you can't, don't worry about it. Obviously, I'm not doing that well myself. I'm getting this shape to be perfect. But I think this looks quite enough. Obviously that's not quite right. I think go a bit deeper, get in there, out. Actually, we want to start there. So let's just tidy this shape up a bit. So this is Jack Marsh's shape. Let's get our eraser out just to get rid of unwanted lines. There we go. Like that. Once you've got rid of those lines you don't need. Good. Now, you guys probably have counted this shape by now. You can see that you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 sides on this shape. So this is one of our first shapes, and all these lines are separated by right angles, whether they're being inside or outside the shape. So there you go. That's your first part, and each of these mini squares represents one length. next, what you can do is you can convert this into a square of some sort. So let this be your height, and you took it like that, and you got it just about right. There we go. There's your square, and we've got to make this a hexagon. Obviously, you might think it'll look like a regular hexagon. It's not going to be a regular hexagon because, obviously, in a real hexagon, you can't have a square inside because it'd be a rectangle. Otherwise, this side can't equal this side. That means this side and this side is not going to equal this side. So that's just like that. Because the angles will never be equal and stuff. So, go up from there. About. And we want. We can still have all of it approximately similar in length. So, do that. Now, obviously, like that. And you can do the same with the bottom. So that's Jack Marsh's shape. I'm going to signify this shape a bit by changing the colors as well. So let there be a dark red in the middle, a dark blue around the sides here, and let's have a dark green at the top. So this can be Jack Marsh's symbol as such. Now let's do some angles for you that we can see. Now obviously let one length. One side. Actually, now the shape is so good, I'm gonna have to save it. File save as Jack Marsh symbol. There we go. There's Jack Marsh's symbol. Obviously. Now let's also get to work. I'm gonna also save it as Jack Marsh annotated. So let's start annotating this shape. So we know that there are going to be right angles there. You can also have a dotted line that went like from here to here, and you can see that this shape can be broken down into units, cubic square units, like this. There we go. And if you counted them, you get 1, 2, 3, 4, 5, 6, 7, 8. So if one side of this shape is going to be of that length, we can say that the area of the red shape is going to be 8 times the area of 1 square, which is 1. 1 squared is 1, so 8. So our total. So 8 in the red. No, we need a bigger font. Let's try it again. 8, let's go up a couple of notches, there we go. So the area of the red is 8. Now let's work out the area of the 9. So we know that this is a square, as you can see, I hope you can see. And what that would mean is, you can see that this has this, we can work out the square's length using a bit of Pythagoras. So we know that this length is 1, and if you were to have, oh, we don't want red, do we? We'll go black, because it's neutral. We don't want to give any advantage to any one color in our flag type thing. Suppose you had a right-angled triangle. You know, and this length is 1. This length, now obviously, half of 1 is half. So these ones are, if I'm not mistaken, this angle should be the square root of half. I'm going to just check that with my notes. It should be about that. Yeah, you can see that, because 1 squared is equal to 2x squared. therefore half is equal to x squared, therefore x equals square root of half. So that's that. We know that that is this length out. That should be right, I think. Actually, not that isn't right, is it? No. I thought you'd actually, it's because 1 isn't the hypotenuse. You gotta remember this is the hypotenuse, so it's actually just 1, and then this would be the square root of 2. Sorry about that. I forgot which one was the hypotenuse. So that means this length is square root of 2. So 3 square root of 2 is the length of one side of the square. So that means 3 square root of 2 times 3 square root of 2 is the area of the blue bit, including this. So that means the area of the entire blue bit is going to be 3 times 3 is 9. Square root of 2 times square root of 2 is 2, so 18. But remember, it's not including this red bit. It's just the blue area selected. So 18 minus 8 is 10. So the blue bit should be 10. I'll do that in our blue color. Here we go. Our next Jack Marsh number. And what we can do is we can work out with these green bits. So we know that this length is 3 square root of 2. And let's see. We know that this, we can see that this might be a right angle, I guess. So this, it's obviously not a proper shape, but this is going to be a right angled triangle, if I'm not mistaken. Cause, yeah, in a real hexagon you'd have different angled sides, 120 or something like that, but yeah, here we've done it simpler, so we've got a right angle, so then obviously that is going to be a right angle. So if it's a right angle, that means that this, we obviously know that this side is going to equal, let's go black, 3 square root of 2. Square root of 2. So, and then we want to work out what one side is about, I think. So you can actually work out what the total area of the green bit is. So we know that that's 3 square root of 2 is that. You can see that. So we know that x squared plus x squared is equal to this squared. So you know 2x squared is equal to this squared. So let's work that out. So square this, you get 18 again. You know that you're going to have to divide that by 2 to get one side square, so you get 9. So that means that each side is about 3. Is 3. So that means 3 times 3 divided by half times 2. Those two cancel out, so you get 9 as your green number. So yeah, so these are the 3 numbers generated by this shape that Jack Marsh has asked me to make. And those should be the values given by this equation, like our Calianic equation. So we can test that using some graphing software. So yes, so this is the graph of x. See, from h of x is equal to this number, as you can see right there. And now we've got to take it and it equals 0. So what are the times it equals 0 at? And it's not just 8 and 10, but it also, so the function returns 3 values. It returns 8. It returns 0 when it's 8, when x is 8, 9, and 10. So that is what that's about. And you can see that right there. Yeah, you can see that. And if you were to just test it, you could go on a cubic graph solver. And do your cubic formula solver. and we could test it by doing, okay, so our A was 1, our B, if we remember, would have been minus 27, our C was 242, and our D was minus 720, enter. There we go. Our 3, did it switch the order? No, it doesn't switch the order that we did it, but yes, that is our thing. Yeah, so that, there you go, there's your cubic equation calculator. So it proves that that equation gives, obviously we could always try and work this out ourselves by using a text edit file. Yeah, let's maximize this. So we know this is the equation. You can always try and factorize 10 out. So you'd get, so suppose it was x minus 10. You can divide all this by that. So yeah, if you could do that, and you would find that whatever remained, you could take it for x minus 9 and x minus 8, and then you can obviously, when that means x is either that number, or that number, to return 0. So there you have it, ladies and gentlemen, Jack Marsh numbers and the Jack Marsh equation. And here we have the Jack Marsh symbol.